All right, section 11.4. We are at the last of the four conic sections, and we're going to be discussing the graph and the equation for the hyperbola. So nothing really to write here. I just wanted to maybe refresh your memory a little bit. This was discussed in Algebra 2. There are two different variations, really, of hyperbolas. This one, of course, first of all, a hyperbola is really two parabolas that open opposite each other in opposite directions. And the reason why this particular hyperbola opens to the left and to the right is because x is the lead variable. Okay, so with x being first, I know that I'm going to be crossing just the x-axis. And I know that since I'm not adding or subtracting to x and y, then I must have a center. The whole center of this hyperbola must be at the origin. And we'll look at some where they're not centered at the origin. They've been shifted to a new spot. So pay attention to the variable that comes first. When x leads, then you're going to be crossing, when the center is at the origin, you're going to be crossing the x-axis only. And the way we make these curves is we're going to sketch a rectangle, and I'm going to show you how that works in just a minute. We're going to sketch a rectangle that's called either the interior rectangle or the central rectangle, depending on which book you have. And that rectangle will help us draw these two green lines called asymptote lines. And we just sketch our curve staying within those asymptotes. We should be approaching forever and ever as we progress up and as we go down. Same thing for this one. The way we find foci is a little bit different, so you've got to change your way of thinking. The way we find foci for a hyperbola is we use the Pythagorean Theorem. When we were dealing with ellipses, this said minus. Notice also the equation for a hyperbola is different. When this was an ellipse, this said plus. So for hyperbolas, this will always say minus. And it's also true, just like ellipses, that to get to standard form, we have to make sure that this equation equals 1. So that's just a sample, and we'll get into how we graph these in just a minute. Let me just show you one more. Notice how now this is a hyperbola, two parabolas that open up and down. And the reason why they open up and down is because this time the y variable comes first. So pay attention to the variable that's in the lead. And that tells you pretty much all you need to know about how these two parabolas open. X is first, they have to open left, right. Y is first, they have to open up, down. Okay? And enough said about that. Let's get into some homework examples. So on problems 19 to 28, your job is to find an equation for the hyperbola described and then sketch the graph. Okay? So there are some similarities to what we discussed with ellipses. We can always label the focus, the focal point is labeled as C. It's 3 units, in this case, from the center to each, really, of our focal points. We're only given one focus, but there's actually 2, and they're both the same distance away from the center. So if you like, you can always label whatever the focus is, that number, label it as C, and vertices, just like ellipses, are always labeled as A. What we don't know is the B. We have to have A squared and B squared. Well, here's something that I do know. With the focus and the vertex, vertices, being on the x-axis, then this hyperbola, when it's graphed, has to cross the x-axis. And so right away, I'm going to go ahead and set up the equation that represents these two parabolas crossing the x-axis. Okay, so something else to adjust your thinking from ellipses. For hyperbolas, it's these numerators that will change depending on the graph. the denominators never change. For hyperbolas, the left denominator is always a squared, the right is always b squared. But from one graph to the next, these could change depending on are we crossing the x-axis or the y. Okay? So my job now is to find a squared and b squared using the information that we've been given. And remember, we're going to use the Pythagorean Theorem to find missing pieces. In this case, we're trying to find b squared. Well, c squared is 9, a squared is 1, and I'm going to solve this equation for b squared, and obviously I get b squared is 8. And so now I've got the equation. It says, first of all, find the equation. A squared is 1, so technically I don't need denominator 1, but I'll go ahead and put it. And b squared is 8. Okay, now let's sketch the graph. So here's like answer part 1. To sketch the graph of a hyperbola, we need a rectangle. It's called the central rectangle most of the time. And here's how we make that rectangle. Sort of like what we did with ellipses. We need the square root of this denominator that's underneath x. The square root of 1 is 1. So I'm going to put positive 1 and negative 1 on the x-axis. And then let's just approximate the square root of 8. Well, it's really, really close to 3, because the square root of 9 would be 3. So I'm just going to make a dot just below 3, positive and negative. Using those 4 dots, we're going to make a dotted rectangle. Okay, so with this triangle, or with this rectangle, we're going to make 2 lines, and these are called asymptote lines. So let me just adjust my line draw here. And I typically make these dotted because they're not technically part of the graph, but they are useful to help me draw the graph. So I'm going to do this. You wouldn't have arrows going both directions in the middle like I do, but this is just to save me a little bit of time. Okay, so we're going to draw 2 parabolas that basically stay within these asymptote lines, and they cross these vertices, positive 1 and negative 1. Okay, remember we already established that with the focus and the vertex being on the x-axis, that's the way the parabolas should open. They should open to the left and to the right. And vertices are where our parabolas cross. All right, so I'm going to draw, I'll just keep it in red. I'm going to draw a parabola that crosses through 1, 0. So you should be approaching but never touching. Try to avoid this. What I'm about to do is not right, but I get people that do this all the time. They just do me some random U-shape. Well, they've missed the whole point of this dotted line. The whole point of this is that I should be, once I cross through negative 1, 0, I should be getting closer and closer forever, but I'll never quite get there. Okay, and now don't forget, part of the graph will be to include the focal points. And we have a focal point at 3, 0. Remember, a focus is always inside the mouth of a parabola. Well, for a hyperbola, we have 2 of those. And so that is our final answer for number 19. Okay, let's try another one. This time we have a hyperbola that it's going to open up and down because my vertex and my focus are both on the y-axis. So when I write the equation this time, I'm going to make y squared be first. And I'm going to find out, using the Pythagorean Theorem, what is a squared and what is b squared. Okay, and you can always label focal distance. The distance from the center to a focal point will always be c, and the distance from the center to a vertex will always be a. So once again, just like our previous problem, let's find out what b squared is. C squared is 36 equals a squared, which is 16, plus b squared. And so b squared is going to be 20. So the equation that's being asked for, a squared, remember, for hyperbola is always the left denominator, and b squared is always the right. Okay, so we've come up with the equation, and let's go ahead and sketch the graph. To make our rectangle, we're going to do the square root of 16 plus and minus on the y-axis, 4 up and 4 down. We're going to do the square root of 20 on the x-axis, and the square root of 20 is about 4.5. Okay, use those 4 dots to do a rectangle. And use your rectangle to help you draw 2 lines that are called asymptote lines. So you're basically going to make an X, line up the center and the opposite corners. And remember, since y comes first, we've already established that because our focus and our vertices are on the y-axis, then this hyperbola must open up and down. Vertices are the points where I'm going to cross. So here's the top half of the hyperbola, and then here's the bottom half. Okay, and then don't forget, we need to also plot the focal points. And we're told that they are at, well, they're 6 units away. There's 2 of them, and both of them should be the same distance from the center, which is the origin. And there's my completed graph. Any questions so far? All right, let's see if we can do another example where the information is not really different here. Maybe we'll just come up with the equation, and to save a little bit of time, if you think you understand how to come up with the graph from the equation, then we'll move on. So once again, the only difference here is they've given us the focal points, each of them. Well, that just tells me that from the center, there's 5 units to each focal point. And from the center, there are 3 units to each of the vertices. So once again, notice where these are placed. The focal points and the vertices, they'll always be on the same axis for hyperbola. Vertices and focal points are always on the same. They're both on the x-axis, so when I write my equation, I'm going to make x squared come first. So it's just our job to find out what a squared and b squared are? We know a squared, that's going to be 9. But I'll give you a second or two to come up with b squared. So remember, you're using the Pythagorean Theorem, c squared equals a squared plus b squared. And who's got b squared? $16? Everybody get 16? Any questions? The big thing is recognizing that x comes first. That's pretty crucial to writing these equations correctly. So I'm going to just kind of summarize what the graph is going to look like. You're going to make your rectangle using these points, +3 and -3 on the x, +4 and -4 on the y. That's going to be your rectangle. Use that rectangle to make your two asymptote lines, and make sure when you draw the graph that your two parabolas are crossing the x-axis. And they should be crossing through 3, 0 and -3, 0. So if I went through that too fast and you don't understand about the graph, let me know. Any question? Yeah?
How do you draw the graph?
Well, you make this rectangle through those 4 points. Then with your ruler, you're going to make 2 lines that cross each other. So you're just going to line up the center, which is, for us so far, it's the origin, and these 2 opposite corners. So you're just going to make an X that kind of looks like this. And then when you draw the 2 parabolas, they should cross. That's what vertices are all about. We should be crossing 3, 0 and -3, 0. And then we'll finish it off by putting in the focal points. -5, 0 is a focal point, and that means 5, 0 has to also be a focal point. Okay, pretty easy so far. Any questions? Okay, thought I'd give you a heads up. This is a different way of giving us information. We're given vertices, so I know what A is. Here, all we're told is the asymptote line is the line y equals 2x. So if we want to, we can go ahead and sketch y equals 2x. So that means it's got a y-intercept at the origin, slope of 2, up 2, right 1. Okay, so here's one of my asymptote lines. That means there's another one. They didn't tell us this, but it's implied. Y equals -2x has to be the other one. There'll be plus and minus. So we're just going to make 2 lines that cross each other. Missed that one. Mine are a little bit off, but I think you get the picture. Okay, so here's the deal about this asymptote line. Remember this 2 represents slope. How do we describe slope? Slope of a line. Okay, that's the equation. How do we describe, give me a formula if you didn't know what the slope is and you know what 2 points on the line are, how can you find the slope? Remember the formula? y2 minus y1 over... Okay, so the big point of that formula is it's always y over x. Y over x. Okay? Well, in this case, I need a way, I know that the x, or I know that the y in this case, it's given as 6. Okay? And I've got to come up with 2. So we're going to have to think about this just a little bit. If it's y over x, y over some x, that's going to make 2. 3. Okay, Cody's got it. So that means my co-vertices, or my b, has to be, in this case, has to be 3. A is going to be 6 because that's what vertices are. So using this idea of finding the slope using y over x, that means the b number that I'm looking for is 3. Well, now it's pretty easy. Well, my equations, or my equation, will it start with a squared? Will it start with x squared or y squared? Depending on where the vertices are. Will I lead with x squared or y squared? Y squared, because the vertices are on the y-axis. Okay? A squared always is the first or the left denominator. What is that going to be? 36. A represents vertices, and if you square 6, you get 36. So what is b squared? It's going to be 9, because b was 3. Okay? And now you're back to sketching the graph. Do you need to see another graph? Do you know how to get the rectangle? This time you're going to go 6 and -6 on the y, 3 and -3. You've already drawn the 2 asymptotes, so you really don't even need the rectangle at this point. So all we're going to do is show this crossing through +6 and -6 on the y-axis, and we'll just draw through those 2 points. And we need focal points. So find out what C is using c squared equals a squared plus b squared. So the focal points are going to be the square root of 45. Let's give it, without a calculator, let's just approximate it. Well, our square root numbers are 36 and 49. Square root of 36 is 6, square root of 49 is 7, so would you say it's closer to 6 or 7? Closer to 7, so it's going to be more than 6.5, right? Let's just say 6.7 plus minus. So 1, 2, 3, 4, 5, here's 6, and our points are going to be just beyond the halfway mark between 6 and 7, and then same thing down here. Okay, this one's a little weird, so any questions on how we, given the asymptote line, how you can come up with a missing piece? Okay, for sake of time, let me go ahead and work one of these from this set of problems. And let me talk about this idea of the transverse axis. All right, well, to begin with, let's just go ahead and sketch our rectangle. So we're going to put +5 and -5 on the x-axis. We're going to put positive 3 and negative 3 on the y-axis. We're going to do our rectangle through those 4 points. And the rectangle helps us draw those asymptote lines. Okay, and which axis am I going to be crossing? X or Y? Well, it's all about which one comes first. So since X comes first, I'm going to be crossing the x-axis. And that's not real good, but hopefully yours is better. Okay. Let's go ahead and do the foci, the focal points. C squared, that's how we get focal points, is equal to A squared plus B squared. So we need the square root of 34 plus and minus. So it's a little less than 6, right? Square root of 36 is 6, so let's just say 5.8. You can, I'm saving a little bit of time. You would just plug that into your calculator, square root of 34, and round it. So my focal points are also on the x-axis, plus minus 5.8, 0. Just almost at 6 and negative 6. Okay, the directions say to find the center. Well, that's pretty easy. What's the center? 0, 0. The transverse axis, let me show you what that means. The transverse axis is, you could shade in the distance between the vertices. So when it says to find the transverse axis, all I'm going to have you do is what I did here. I just want you to shade it in on your graph. It's going to be the connector between the 2 points that your graphs actually cross through. So if it's the equation starts with x, the transverse axis is always going to be horizontal. If the equation starts with y, then it should be vertical. Just shade in between these 2 vertices, and that is the transverse axis. The vertices, how would we show the vertices as ordered pairs? What are the ordered pairs of the 2 points that we're actually going through? Plus minus 5, 0. We've already done the foci, and we've already drawn the asymptotes. What are the equations for these 2 asymptotes? Plus minus 5/3 x. So I must be off. I think that's flipped over. It should be 3/5 because it's always y over x. And I need to reduce, but if you want to know the equation for the asymptotes, take the y denominator. Remember, it's always y over x. Whatever the y is, put it over the x. It's always y over x, and then you can reduce. And I think we're done. Okay, hold on a second.